section is pretty easy. It's really mostly review. Always the one thing I start with, though, is if you were to describe to me what a circle was, what would you say? Round, but, you know, can't round be interpreted in different ways?
When I think of circle, I think
Spherical, I mean, that's in the, but what I want you to do is try to think of a way that you could describe a circle that I couldn't argue with.
3.14.
Never-ending clothesline would be okay, except I could draw a curved never-ending close, but a line is straight. It can't curve. Does that make sense? So you're on the right track, though. You know, you can't say it's something without angles because I could draw an oval, couldn't I? And that's not a circle. You couldn't say it has curves, but what do you think?
Multiple points.
Yeah, I was gonna say a set of points.
That's pretty much it right there. I want you to think of it like this. This is, as we all know, called what? The radius. Okay? And radius is important because no matter where that radius is always what? It is the what? The distance from the center of the circle to the circle. And some people like to say the outside of the circle, but in essence that's the circle. This part right here is the circle. So it's the distance from the center of the circle to the what? To the circle itself. Now, if this was 5 centimeters right here, does this change at all if I decided to draw it right here? What's that distance?
5.
And then if I tried to draw it right here, what would that be? Okay? No matter where I go, what is this distance going to be? As I go around it, center to outside. That's the perfect way to describe a circle. Is what happens is, you know, if you just had to draw a bunch of dots, all the dots that were equidistant from right there, they would all infinitely come together to create where they didn't look like a dot anymore, right? You know, see if I draw a dot here, I draw a dot here, but then I draw the one in between here, the one in between here. You know, you can see how eventually this becomes kind of a solid, I couldn't say line because it's not straight, but solid curve there. That's what a circle is. That's all a circle is all the points that are the same distance from this one point. So it would make sense if I called this point C. How do you think we'd name this? We'd call it circle what? The important part is the what? Center. That's what it all centers off of. That's where it's equidistance from. So with that in mind, you know, when I worked on, we had to, we were edging up this summer actually, and I've done it for years, of course, like this, but see if you guys can think of how I did it. I needed to mark where I was going to edge up the circle for the mound on the practice infield at the baseball field. How would I do that? How would I make a circle? I mean, how in the world would you make a circle out, you know, I mean, if we all tried to do that offhand, I guarantee it'd be pretty ugly, wouldn't it? How do they do that? How do you think how do you think I did it? Anybody have a guess? Well, yeah, put something in the middle. Yeah. Well, I'll just tell you this: a mound is supposed to have a 18-foot diameter or a 9-foot radius. So how would I do it? How would I mark it? You could use something like paint, right? Spray paint. He's almost exactly right. 9 feet long. And that's exactly what I did. I got a big nail, stuck it in the middle where I wanted the middle of the mound to be, got one of those spray paints that you push down and sprays a line, got a string, made a circle, measured my string to where I knew from the string to about the middle of that can was 9 feet, pulled it tight. Of course, it was probably a funny sight if you saw me doing it, You know, you're kind of trying to pull it tight and walk in a circle real fast while you're what? Turn the paint on. You'd be amazed how good that circle looked. But I mean, that's the concept, really describes the concept of what a circle is really well. Because, you know, at each point, because I was pulling it tight, I was 9 feet away from that center the whole time, wasn't I? And that's, you know, that's how I did it. Exactly how I did it. And, you know, fun story, just to get a concept of what circles are. Now, things we need to know. There's also, you could also draw a segment. This is just a segment from what? The center to the outside. We could also draw a segment like this. Call this point A and this point B. You guys know what this is called?
Chord.
AB is an example of a chord here. Its endpoints are what? Are on the what? Circle. Endpoint B and A are on the circle. That is what makes something a chord. Some people think that, heard someone say, that doesn't go through the center. No, the ones that go through a center, go through the center right here. The chords that go through the center is just kind of a, I guess you could say, a special type of chord. What's it called? Diameter. So EF is a diameter. Because why? It goes, we can say goes through, I know there's probably a more mathematical way to say that, but goes through the what? Center of the what? Circle. And then we talked about what radius was, didn't we? We got to understand the basics here, okay? We got to, you know, be able to understand what diameters and radii are. That makes sense? One thing that you'll use a lot, that you guys don't realize, and that we'll use in actually in some sections to come. Don't draw this. I'm just going to make a point here of something. You'll have problems like this. They'll say this is 90 degrees, okay? They'll say, hey, what's this length right here if this distance was 10? And that's all they'll write. And of course, I'm talking about this distance from here to here, aren't I? That's why they wrote it right here. If they wanted it to be the whole thing, they'd... Do you realize there's enough information there to find that? But what simple thing has to put you in the right? What do you have to see? Anybody? You have to realize that a radius is a radius no matter where it is. Just because we didn't make dots or make it look just like that, a radius is still just simply the distance from what? The center to the circle. And it's the same no matter where it is. So what's the distance from here to here? What's the distance from here to here? It's still 5. It doesn't change, does it? So now all of a sudden I have basically a right triangle where the hypotenuse is what? 15, this side's 5, and that's x. Now is that a hard problem? But what had to push you in the right direction? Just realizing that a radius is a radius no matter where it is. But the triangle kind of just throws you off from seeing that, doesn't it? You'll have problems like that where you have to realize that, hey, a radius is a radius no matter where you draw it. Okay? The other thing to quickly talk about, and I'm going to draw a quick freehand circle. We have perimeter, right? Which talks about starting on a circle and then walking what? All the way around it. That would be perimeter as far as polygons are concerned. What word do we use for perimeter? And do you guys know the formula for circumference? Use a capital C is equal to, one you see a lot is pi d, or you see C is equal to what? 2, no, 2 pi r. That's area when you're squaring the radius. Why do either one of these work?
Because 2 times the radius is the same.
A diameter is the same as saying 2 times the radius, isn't it? It's just that this here, if I wrote this like this, would it make more sense? I just wrote it in different order, didn't I? Because we usually put the variables by each other, don't we? Make sense? Sit up. Sit up. Sit up. Any questions there? Okay. Let's go back up here to this, and I want you guys to find the circumference of this circle up here. How am I going to find it? Pi times d, or what could I use? You could use either one. What's the diameter of this one? The diameter of this up here is what? 10 centimeters. What's the radius?
Well,
It doesn't matter which one you use. Which one do you guys want to use? D? Okay, so C would equal to pi times what? What's the diameter? 10. Okay. What I want you guys to realize is there's two ways to give this answer, basically. One where they ask you to round. In our case, we'll round to the 100th. And then when they ask you to give the exact answer. Now, how do you think I'm going to do exact?
You're just gonna put 10 pi.
That could be a way.
31.
First, let's round to the 100th. How about that? Now, how many of you's first thought was to put 3.14 in for pi? It's okay if it was. But what kind of button do you all have on your calculator? 5 button, and it takes it to a lot of decimal places, doesn't it? Here's the thing, though. There will be times where you put 3.14 in. Do you guys know when that'll be? Have you guys ever done a problem where they ask you to put 3.1 in? A lot of standardized tests, don't they? You guys ever taken a math test? You guys remember saying, okay, and then they'll say use 3.14 for pi. Well, in that case, use 3.14 for pi. If they ask for something in the hundredths, though, on a test like this, because you're getting into the level test where they'll allow you to have a scientific calculator, so they may let you use the what button? The pi button. If they don't ask you to use 3.14 for pi, do not use it. If they ask you, then what? Use it. Okay? That's simple. But if they don't ask you, they want you to be as precise as you can, and you always want to use the pi button as late as you can in doing it. The last thing. Because if you round it or something early, you might get an answer that's a little off. In fact, the test we just took, we had 3 fill in the blanks at the end. I had some people who, by no fault of their own, I went ahead and counted them right. They went ahead and said, okay, the cosine of 40 is 0.82, right? They rounded it to the 100th and put that in the equation when we cross-multiplied before they cross-multiplied and solved. So where one answer I think was 352.7, they had 352.3 because they rounded the cosine of 40 up before they started dividing. And so what happened was, what they should have done is when you got to the end, they should have done, something divided by cosine of 40. They divided by just 0.82. So it threw their answer off a little bit. Okay? You always, when you're doing things like that, if you don't like solving equations like that, if you're around to the 100th, if I'm doing a number early, I'm going to take it to 5 or 6 decimal places just to make sure I stay accurate enough as I need to. Okay? That's going to be on my soapbox for a little bit there. But the exact, for the round of the 100th, what would your answer here? What'd you guys get? Put it into your calculator. 10 times 4159 what?
2654.
Okay. And then that's approximately what they ask you to round to, 31 point what? 42. That's right, isn't it? Or was it 419, wasn't it?
4159.
4159? Okay. So we round up to 42. That's good. Centimeters, not centimeters squared, just centimeters. Now, the exact answer. You guys remember when I had you guys square root of 18? That'd be square root of 9 times square root of what? 2? 3 square roots of 2, and I told you guys that's the exact answer? Or that's the
Simplify.
your only exact answer you can have, because square root of 2 is a non-terminating, non-repeating decimal. Yeah, you could round it, but it wouldn't be exact. Same thing here. The only way to write pi times 10 exactly is to simply 10 pi. It throws people off at first, but you'll find that that's actually the easiest way to do it. Here, we rounded. Here we didn't. You guys understand that? Okay. Any other questions? All right. Let's get out your workbooks.
What was the other,
I'm recording this, so you can get it later from the online if you need to.
well, it was pi times the diameter or what? Whole circumference?
2 pi r. I'll give it to you here in a little bit, okay? All right. I think it's 123. Not going to write a lot of these down. I want you guys to look at this with me. No, keep your pen. I will freeze it on the problems that we write stuff down on after we're done and zoom out so you guys can write it down. So I just want to listen and go through this so you can get started on your assignment, because most of this assignment is really easy. I mean, you guys can have problems with this. Name the circle. What would you name that? Circle P. You would make the circle sign with a dot and say P. Name a radius. Well, how many do you see there? 1, 2, 3. Name any one of those, but how are you going to name it? You have to say it as a segment with a segment on top. You can't cut corners there. Okay, name a diameter. There's actually only one right answer here, and it's what? I mean, or a BA, segment BA, but, okay, name a chord. AB, segment AB would be fine as a chord too, wouldn't it? Probably all of you are going to probably say DE though. But name a radius that's not drawn as a part of a diameter. What's the only one that could be? CP. Okay, suppose the diameter was 16. What's the radius going to be? Well, you don't even need a picture for that, do you? It'd be half of it. It'd be 8. Say PC, they say PC is 11. Well, that's a radius, right? So what would AB, which we already said was a diameter, have to be? 22. Pretty easy, huh? This one's a little bit harder. I'm going to zoom in so the picture's a little bigger and count on you to read the directions. But in this problem, they basically say that your diameter of the bigger circle is 6. Okay? The diameter of the smaller circle is 5. So, and this is what gets a little weird here, and you kind of, okay, from here to here is how much then? That's from the outside. G is the center, right? So what is that? If the diameter is 6, what is that? Wouldn't that be 3? So from here to here would also be what? Now, what about from F is the center of this one? From here to here would be what? 2.5. Right? Now, 2.5. Now, they ask for BF. What would that be?
0.5.
That right there, you're right, would be 0.5. Agreed? That would be 0.5, right? It's just kind of weird, though. So then they ask for A to B. Now, your first thought is going to be, hey, that's the radius, right? But is it? It goes, the A radius is from A to F. So if that's 0.5, what's left for it to be? 2. Fun, huh? Staple your view something to the back of the answer sheet.
Are all of them going to be like this?
No. I mean, that's not that bad. It wasn't so bad when you labeled it, was it? You see, I was very, I don't know, methodical about the way I labeled it to make sure I was doing it correctly. I'll let you know a little secret. If I made a mistake at first and did that wrong in the first hour.
Did you find a black folder in the?
Just for a second I did.
You did? Thank you. I had it finished, that's why I didn't take it. Thank you.
Okay. All right, for these, they ask us to find the exact circumference. Oh, I'm sorry, we jumped away. 10. I jumped ahead. It says find the diameter and the radius. So they want us to find the diameter and the what? Radius. What did they give me? Okay, what is circumference equal to? Pi times d, or what? 2 pi r. Which equation do you want to use? Anybody? Staple review assignment to the back. Pi times d, did you say? So I'd put 36 in for what? C right there? So 36 is equal to pi times what? D. Now, pi is just a what? It's just a number, is it not? It's just a number. So what should I divide both sides by here if I want to solve for d? By pi. Because wouldn't that leave just d equal to? Because that divides into 1. Well, now it says round to the nearest hundredth. What do you guys get when you put this into your calculator? Would you tell me? So 11.46 meters. What would the radius be then?
5.7295.
So 5.73 meters. Not too bad, is it? It's just simple algebra, to tell you the truth. Now, 14. We're going to have to do some little bit extra stuff here. First of all, this is a 90-degree angle, and they ask us to find the circumference, the exact circumference. So, what am I going to do? Well, what do I need to find circumference? I need diameter or radius. Do I have either one of those here? No, they have not given me the diameter nor the radius. They said that this is 3, these are congruent, so what's that make this? This is 90, so what do those have to be? Didn't we just go over this? Now, so if you remember your shortcuts here, this is the hypotenuse, is it not? The hypotenuse in a 45, 45, 90 triangle is always equal to square root of 2 times the side. So that means this one's 3 square roots of 2. That's what your diameter is. Now, if you don't remember how to do that, what theorem could we use here? We know that this is 3 and this is 3. What theorem could I use? You have 2 of the 3 sides of a right triangle. Anybody? Kellen, what do you think?
Cosine.
Kellen, what do you think? What theorem could I use? Huh? Pythagorean's theorem, which says that the square of the 2 legs added together will equal the square of the hypotenuse. So what, using the Pythagorean's theorem, what would it be? 3 squared plus what? Equals, that's the diameter, isn't it? So I'll just say d squared. What is 3 squared?
9.
Plus
9.
equals, what is 9 plus 9? What do I do now? Square root of both sides. What is this? Square root of 9 times square root of 2. Is that not the same answer I just got? And you have to leave it like that because they ask for what? Exact. It is not an exact answer if you make this round this and make this into a decimal and then leave the pi on it. You have to leave that like that as well. So, my diameter is this. My formula is to multiply pi times whatever the diameter, and that's 3 square roots of 2. How in the world am I going to write that? Anybody have any guesses? There's kind of two ways you could write that. You could do this, write it as 3 square roots of 2 pi, or you could write it as this, 3 pi square roots of 2. Now, which one do you think is the correct way to write it?
Three square roots of two,
The second one.
All of you that said the second one, you are correct. Do any of you know why? Just out of curiosity.
Because when you say you'd be multiplying pi by the square root of 2 if you wrote it the other way.
Well, you're multiplying pi times square root of 2 the other way. In my humble opinion, what if I did this? I mean, this is what if I did that? What's confusing right there?
it makes it look as if it's underneath the square root.
How do I know whether you're trying to say that this is under the square root or not? See how it's kind of open-ended on this side? This is just simple, what makes more sense. Here, there's kind of a question mark in there. Right? Is it under that or is it not? Who knows? Here, is there any question? Here, is this square root of 2 pi or is it pi times square root of 2? Here, there's no question because the pi is in front of the what? Square root. When you're writing these, you always put your square root last because square roots are open-ended on that side, so it's confusing. It's just that simple. It's why you put y in an ordered pair. The reason I don't write an ordered pair like that. Is that a 31 inside of parentheses or is it a 3 and a 1? Well, if I put a comma in between there, what is it? A 3 and a 1, right? It's all about communicating. Just trying to help you understand why. When you have a square root, it always is last because it's open-ended on this and there'll be some confusion. Make sense? Okay, go on to the next one. So that's your answer right here. Do not write it like that. Is this really any different here? They still want us to find the circumference, pi d. What situation do I have here? What's this?
That's
Is this a 90-degree angle? Don't I just have this situation here? And this is my diameter? Would everyone agree with that? Well, I need that diameter, don't I? If I'm going to find a circumference, I need to know what that diameter is. Well, how am I going to do it? Just like I did over here. 8 squared plus what?
15 squared.
Is equal to what? D squared. What's 8 squared? Plus what's 15 squared?
200.
Equals what? D squared. This becomes 289 is equal to D squared. What am I going to do next?
Square root.
Square root of both sides. Now, word of advice, especially when you have some of these big numbers. Don't kill yourself trying to simplify this until you make sure it's not a perfect square. I don't know if that jumps out at you as a perfect square, but put it in your calculator and see. If you get a decimal, then it's not a perfect square, is it? But when you put square root of 289 into your calculator, what do you get out? 17. So that's your diameter. So your circumference is simply, and this is what is great about leaving it as exact. What's the circumference? Just 17 what? How easy is that? Okay, assignment-wise, your assignment 1 through 6, 9 through 21, 28 through 33. Write problems, draw figures, show all steps, and work. We're going to get this chapter done before spring break. Now, how I'm going to help us do this, there are 6 sections in this chapter. What I'm going to do to help us is on 8.2, 8.3, 8.4, and 8.5. I'm going to assign you worksheets instead of work from the book.
Thank God.
That's what we're doing next week. I'm sorry, did I say that? Oh my gosh, on all of these I wrote 8.2. I should have wrote 10.2.
Uh-oh.
Wonderful. Anyhow, that's not a biggie. We'll just have everybody write them out, or mark through them. But anyhow, that's what we're going to do next week, so we'll get through 10.4 next week. Then we'll do 10.5 and 10.6 on Monday, which is probably the hardest two of the chapter.
10 what? Or
10.5 and 10.6 on Monday next week. And then we will test on it on that Friday.
Yeah.
And we'll review on Wednesday and Thursday and finish this stuff up, answer any questions on Thursday. I'll say you can do the workbook problems for extra, for credit for as a review assignment, but it will be extra credit for sure on the test, so. Okay?
Question.
All right.